This lesson is on the chain rule, and the chain rule is where we're going to be taking the derivative of a composition, which means when we have a composition of functions, we have an inside and an outside function. So what the chain rule does is the chain rule says we're going to take the derivative of the outside and multiply it by the derivative of the inside. And I'm going to show you that basically through examples. So let's look at number 1. The outside function is a squared power. It's an exponent, so we're going to apply the power rule. So 2 comes in the front. We copy the base exactly as it is, reduce the power by 1. Now we go inside the function and we're going to take the derivative of the base, which is 3x squared plus 4x. So again, the outside is the power rule and the inside is the base. And now we're going to just simplify it. So if we put the 2 through, we get 2x cubed plus 4x squared. And we're going to multiply that by 3x squared plus 4x. And then it's just FOIL to get to the end. Now, if the powers get too big, we're just going to leave it. We're not going to make a big to-do out of it. So 6x to the 5th plus 20x to the 4th, and then plus 16x to the 3rd. And then that would be your derivative using the chain rule. Okay, this next one, one of the things to mention is that the derivative of e to the x is e to the x. So when we go to do this one, we would say f prime of x is equal to e raised to whatever power it is, and then we take the derivative of the exponent, which is 2x. And then really, all we can do there is rewrite. So f prime of x, 2x e to the x squared. And that would be your derivative there. So remember, the derivative of e to the x is e to the x. Okay, now we've got a power rule. So we're going to, first things first, we're going to apply f prime, the power rule. So we're going to bring a 2 down and 1 over x plus 1 to the first. So that applies our power rule. And now the derivative of the inside is a quotient rule. So low x plus 1 times d high, which is a 0, minus 1 times the derivative of the low, which is a 1, over x plus 1 quantity squared. So that takes care of our derivative. Now we simplify. So f prime of x, 2 quantity 1 over x plus 1, and then we'll simplify in here. We get a negative 1 over x plus 1 quantity squared, like that. And then putting it all together, our derivative is negative 2 over x plus 1 quantity cubed. And that takes care of our derivative there. So again, the outside was the exponent, and then the inside was the quotient rule. Okay, number 4 looks a lot like number 1. And I picked it because I kind of want to show where our work will stop. Okay, outside power 3, copy the base, 3x minus 2x squared, reduce the power by 1, 2, times the derivative of the inside, which is 3 minus 4x. And then down here, f prime of x, I'm going to put the 3 through the second factor, which would be 9 minus 12x, and then 3x minus 2x squared, and that quantity is squared. And at that point we're going to stop because it really doesn't, the work becomes quite a bit of a drudgery, and it really, for us to simplify that, the derivative will be fine. And next year your calculus teacher will be more specific with what how far they want you to go and in what scenarios. I'm going to rewrite this next one as with a negative exponent. Now we're going to go ahead and use the power rule. So 14 times 2x minus 3, reduce the power by 1, negative 3, times the derivative of the base of the exponent, which is a 2, and then f prime of x, 28, times 2x minus 3 to the negative 3. And remember, negative exponents, it just depends. Usually they'll want you to put that in the bottom, just if it's simple. 28 over 2x minus 3 to the third. And that was, again, the derivative with the chain rule. The chain rule is an essential in calculus, and definitely something that will be used a lot. So it's very, very important to do. Okay, here we go. Last one. So f prime of x, the outside function is an exponent. The inside function is a quotient. I bring down the 2, 3x minus 1 over x squared plus 3. Okay, that's the power rule. Next, we're going to take the derivative of the inside, which is a quotient. So low x squared plus 3 times the derivative of the high, which is a 3, minus the high, which is 3x minus 1, times the derivative of the low, 2x, all over the derivative on the the low, the denominator, no derivative there, squared. So at this point, that takes care of the calculus. Now what we're going to do is simplify and see if we can write that a little bit simpler here. So I'm going to put the 2 through multiplying wise. 6x minus 2. Actually, I'm just going to write that. We'll leave the 2 because I don't know if that'll cancel yet. So let's leave that. Over x squared plus 3. So let's take that. And now let's simplify on the inside and see what happens. So 3x squared minus 9 minus 6x squared plus 2x all over that quantity x squared plus 3 squared. Okay, now we'll simplify again. So really the chain rule starts it, and then it becomes just a big old fat algebra problem. People will often say the calculus is easy, it's the algebra that's terrible, and that's a very accurate statement. You'll find that out more next year as you go into taking the calculus. All right, so negative 3x squared plus 2x oops, just found a sign mistake. I bet some of you are probably envisioning that as we go, right there. Just like when we're together, plus 9, okay, all over that quantity. So really, all we can do here is do f prime of x, and we're just going to make it look pretty. 2 times 3x minus 1 times negative 3x squared plus 2x plus 9. And we're going to put that all over. And then on the bottom, we have x squared plus 3 quantity squared. So there's a nice intro there into the chain rule. And remember, the derivative of e to the x is always e to the x.